All right, so in this problem, we are basically trying to figure out which precipitate, oh my goodness, will form first, calcium hydroxide or iron 2 hydroxide. And at first, you might look at these and go like, oh, I can just look at the KSP values, compare those, which would be great if these were the same concentrations, but they're not. So we have 0.14 molar calcium nitrate. So we have 0.14 molar of calcium and 0.25 molar of iron. So we don't know, it's not like we have an equal number of calcium and iron to know who's going to form the precipitate first. So we're basically going to be figuring that out. So these two share a common ion of hydroxide. So first we're going to figure out what's the maximum concentration of hydroxide each one of these can hold. And then we're going to basically see which one is smaller to see, well, who forms first, because the number of hydroxide ions max, if you reach your maximum first, then you're going to form a precipitate first. So that is what we're going to do. So for calcium hydroxide, we have to find the maximum concentration of OH that it can hold. And we're going to find this using the KSP value. So remember, the KSP is equal to the concentration of calcium times the concentration of hydroxide squared. So the concentration of hydroxide is going to be equal to the square root of the KSP divided by the concentration of calcium 2 plus ions. We know the concentration of calcium 2 plus ions based on the molarity that was given in the problem of what we're starting with, and we know the KSP because that was given. So we find that the maximum concentration of OH ions that can be in the solution before equilibrium, so before it's saturated and precipitation starts to happen, is 7.6 times 10 to the negative 3 molar. Next, we're going to find the maximum concentration of hydroxide ions for iron 2 hydroxide. And it's the same process. We know that the KSP is equal to the concentration of iron times the concentration of hydroxide ions squared. So the concentration of hydroxide ions is going to be equal to the square root of KSP divided by the concentration of iron ions. We've been given the concentration of iron ions because it's a 1-to-1 ratio from the concentration that was given of the salt solution. And we know the KSP value because it was also given. So the maximum concentration of OH ions that can be in the solution before equilibrium and at equilibrium when things start to precipitate is 2.5 times 10 to the negative 7 molar for OH minus. So now we can compare those two values. 2.5 times 10 to the negative 7 is smaller than 7.6 times 10 to the negative 3rd, which means the solution will reach that smaller maximum first for iron hydroxide. So iron 2 hydroxide is going to precipitate before the calcium hydroxide. Okay, so yeah, that was a wild example, but we do have a worksheet to work on for this section. So let me know if you have any questions. Again, a lot of these problems are you're going to be given KSP and you have to find concentration, or you have to find the solubility, which remember S is the molar solubility. And remember that molar solubility is related to 1 mole of the formula unit. So if you produce 2 moles of an ion, it's going to be 2S, not 1S. But let me know if you have any questions, and have a wonderful day.